All right, this problem is a little bit more interesting, a little bit more complicated than the last. And what we're going to do is we're going to build up some answers based on earlier ones. So this figure that we're starting with here, we have this blue circle inside of which we have an inscribed square. And on the side of on each side of that square, we have semicircles drawn that have the sides of that square as their diameters. And the only given measurement that we have here is that the length of the radius of our circle and the radius of our square, OA, is 2. So the first thing we want to find is the side length of the square. So recall from an earlier problem that if we divide our square up into 4 triangles like we have here, each of those is an isosceles right triangle. So if that's 2, that's also 2. And so what we're looking at is a 45, 45, 90 isosceles right triangle whose hypotenuse, in this case AB, is just going to be the square root of 2 times the side. So this is just 2 root 2. And AM is half of that, so AM is just a single root 2. If we wanna label that. Okay, so we're gonna need those measurements in order to find some of these other things. So the first thing we want to find in number 49 is the area of essentially that whole circle. So the fact that it has a square inscribed in it at this point isn't really relevant because the entire circle is shaded in. So all we need to know here is our radius, which is 2. So our radius is pi times 2 squared, or 4 pi. Easy peasy. Okay, so then to get the area of the square, yes, I really just said easy peasy. Okay, so to get the area of our square, we want our side lengths squared. And we found that our side length AB is 2 root 2. So we want to square 2 root 2. If I square 2, I get 4. If I square root 2, I get 2. And so here our area is 8. To get the remaining shaded area when we remove the square from the circle, so this bit that's left in blue in number 51, all we have to do is take the area of the circle minus the square. So we're looking at 4, let me get myself a little bit more space. We're looking at 4 pi minus 8, and there's nothing really we can do to simplify that. All right, well, this shape is made up of 4 of these smaller shapes that we see in problem 52. And so to get a single one of those, I'm going to take 4 pi minus 8 and divide it by 4, which gives us pi minus 2. All right, for number 53, I'm not quite building on the previous information as much. For this one, I need to go back to my original picture. And I notice that this is one of those semicircles that's drawn on the side of that green square. And my radius here, remember we found AM to be root 2. So area of a semicircle is going to be half of pi times the radius squared. If I square the square root of 2, I get 2. A half of 2 is 1. And so this is just pi. All right. And then that little crescent shape that we're left with when we take the area of the semicircle in 53 and subtract the blue area in 52 is going to be pi minus 2, which gives us positive 2. And then if we want the area of all 4 of those crescent shapes, I'm just going to multiply that 2 by 4, and we get 8. And what's kind of interesting here is that those crescents have exactly the same area as the square. So the area of 4 crescents drawn on a square is equal to the area of the square. That's pretty cool.